We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system now. Astronomers have captured that moment live.
Something has just shattered the rulebook of our solar system. Astronomers are sounding the alarm over a colossal wanderer, 3I Atlas, only the third confirmed interstellar visitor in human history. But this is no ordinary cosmic passerby. This giant, spanning nearly 8 miles across, has shifted its orbit in ways that defy every law of celestial mechanics we thought we understood. Neither the pull of gravity nor the violent jets of gas that usually shape comets can account for its bizarre movement. It's as if an unseen hand has taken hold of it, dragging it along a path written nowhere in the mathematics of the cosmos. Traveling at a blistering 60 kilometers per second.
Look at that bad boy.
This is a raw image, so this is not even this is just directly from the telescope right now.
Atlas slices through the solar system with a speed that mocks the grip of the sun. At that pace, it is destined never to return. Its trajectory ensures it will escape forever into the abyss. Yet, speed is only half the story. Atlas is massive, dwarfing the first two interstellar visitors. Its estimated diameter stretching between 3 and 7 miles. A cosmic intruder, larger than any alien object humanity has ever dared to track. The mystery deepened on July 1st, 2025, when astronomers with the Atlas survey caught sight of something that should not exist. An interstellar body that bends the rules of physics before our very eyes. Humanity's finest instruments recorded its strange defiance, leaving scientists with a haunting question. If gas and sunlight cannot explain its rebellious flight, then what hidden force is at work? To put this into perspective, Halley's Comet, long hailed as one of the giants of our skies, measures just 7 miles across. And yet, in cometary terms, Halley is considered colossal. Now, within mere hours of Atlas being spotted, observatories across the globe scramble in unison, their telescopes locking onto an enigma unlike anything charted before. The orbit isn't just hyperbolic. It's almost a straight shot through the solar system, an escape path with an eccentricity over 6. That number alone doesn't just bend the rules, it obliterates them.
You're looking at a piece of what would have become a planet in another star system. This is a building block from somebody else's home.
Every piece of data screams the same thing. This is an outsider. The trajectory, the size, the terrifying speed, all of it marks Atlas as something alien to our solar system. And yet, as information continues to pour in, one detail overshadows the rest. As 3I Atlas barrels inward, brushing dangerously close to the inner planets, its path begins to tilt. Not dramatically, not in a way the naked eye could ever catch, but subtly. Just enough to trigger alarms among the world's most brilliant orbital modelers. This is where the comfort of science collapses. The usual suspects, gravity, solar radiation, even the roaring jets of volatile gas that often push comets off course, can't fully explain this strange swerve. Atlas is no fragile snowball of ice. It is a cosmic heavyweight, a behemoth with enough mass to laugh at most external forces. And yet, it shifts, as though compelled by a hidden directive. The mathematics we've trusted for centuries, the celestial rulebook that has governed every asteroid and comet, suddenly appears incomplete. For astronomers, this is no longer a fascinating curiosity. It's a crisis. If something this vast, this fast, can twist the laws of motion right in front of our finest instruments, then the question becomes chilling. What other cosmic intruders might be slipping past us, unseen, rewriting the story of our solar system? What else could be slipping past our gaze, hidden in the vast dark between the stars? The stakes here aren't abstract. They cut to the very limits of human knowledge and what it means when the universe dares to throw us a curveball we cannot explain.
3I Atlas is moving closer to the sun. There's still so much we don't know, and with the sun's glare taking over, our window to see this interstellar visitor from Earth is closing fast.
If you're the kind of person who craves the unraveling of cosmic mysteries, who longs to see the rulebook of science torn open and rewritten before your very eyes, this is your moment. The saga of 3I Atlas is only beginning, and the next chapter could reshape everything we thought we knew about what drifts through our celestial backyard. We like to imagine comets as neat travelers coasting smoothly along their orbital rails. But the truth is far messier. Their journeys are never straight lines. They're battles, constant tug of wars between gravity's relentless pull and something far more unpredictable, outgassing. Picture this. A comet is little more than a frozen, dirty snowball, locked in ice for eons. But as it creeps closer to the sun, that icy prison begins to crack. Hidden reservoirs of volatile material ignite, vaporizing into plumes that burst from the surface. Sometimes these eruptions explode in dazzling geysers, stretching thousands of miles into space. Other times, they seep quietly, like a whisper of steam. Each jet acts like a miniature thruster, nudging the comet in random directions. The effect is eerily familiar, like releasing a balloon and watching it dart wildly through the air, propelled not by strings or engines, but by its own escaping breath. For decades, astronomers have wrestled with this chaos, translating it into cold, precise mathematics. One of the most spectacular lessons came from the Rosetta mission, which shadowed Comet 67 CP Churyumov-Gerasimenko up close. Rosetta revealed just how powerful these invisible engines can be. Astonishingly, only about 10% of 67P's surface did most of the heavy lifting, firing out plumes of gas and dust that not only altered the comet's trajectory, but actually spun its solid nucleus faster or slower, depending on which jets roared to life. Every orbit became a kind of dice roll. Each eruption tilted the balance, and over time, these outbursts accumulated, subtly rewriting the comet's path. Astronomers soon realized that without including such non-gravitational forces in their models, predictions would spiral into error almost immediately. What appeared random was, in fact, governed by invisible math, tiny thrusters built into the comet itself. The rule is simple, at least in theory. The more gas a comet releases, and the faster that material blasts into space, the stronger the push. Scientists even measure the ejected mass in kilograms per second, calculating the force as though the comet were a spacecraft firing its engines. For most comets, it is water ice that shoulders this burden. Sunlight strikes, the ice vaporizes, and jets of steam and dust explode outward at hundreds of meters per second. The result? A slow but steady drift, nudging the comet off the clean, predictable rails of gravity alone. Over decades, that faint whisper of thrust can carry a comet thousands of kilometers away from its expected course. But there's always a catch. The strength of that push depends entirely on one critical factor: the comet's mass. A small, fragile nucleus is easy prey for the sun. Lightweight bodies can be nudged with the gentlest puff of gas. But a massive, dense nucleus is another story entirely. It is stubborn, resistant, requiring an immense amount of force to shift even slightly. That's why the details, how much gas escapes, how quickly, and exactly where on the surface those jets ignite, matter so profoundly. This is the cosmic language of comets. From Halley to 67P, every significant visitor has followed this rulebook. The formula is deceptively simple. Know the jets, know the mass, and you can forecast the motion. This is the sacred playbook astronomers reach for every time a new comet streaks into view. Gravity lays down the foundation, yes, but outgassing writes the footnotes, the subtle corrections that turn predictions into precision, and time after time, the math has worked. The jets explain the drifts, the models anticipate the deviations. The universe behaves as expected, until now. With 3i Atlas, the old certainty begins to unravel. Orbital prediction is supposed to be a solved problem. You take the numbers, mass, velocity, solar gravity, planetary tugs, and the path of any comet or asteroid should unfold with machine-like accuracy. But with Atlas, those calculations collapse. The numbers fight back, refusing to align with observation. Its eccentricity alone, 6.141, traces a path so extreme it is practically a straight shot through the solar system. A geometry so rare it makes even the most seasoned dynamicists pause in disbelief. But the real crack in the system appears when you overlay the predicted path with the actual sky data. Each observation arrives stamped in time, with precise coordinates and a margin of error. Collect 100 of these, and a pattern should fall neatly into place. One that mirrors the equations not just in theory, but in the living heavens above. Except with 3i Atlas, the universe refuses to cooperate. The residuals, those tiny differences between where Atlas should be and where it actually glows, begin to drift. Not dramatically, not enough for the untrained eye to notice, but enough that the model and reality refuse to snap together. Instead of harmony, there is a quiet dissonance. For a normal comet, these gaps are quickly closed. A tweak for gas jets here, a dust plume accounted for there, and the model aligns once more. But with Atlas, the corrections collapse. The magnitude of the offsets simply can't be erased by the usual suspects. No matter how they bend the equations, the comet's path keeps straying, subtle, stubborn, and relentless. Across observatories and datasets, the deviation persists. Engineers and orbital modelers scramble, running the numbers again and again, feeding in every known force: the sun's inexorable pull, the gentle tug of planets, the faint pressure of sunlight itself. And every time, the result comes back the same. Atlas does not obey. The models strain under the weight of Atlas's defiance. The anomaly is no longer a statistical blip. It is carved clearly into the residual plots, the comet's actual position drifting systematically away from prediction. Not random scatter, not noise, but a pattern, an unmistakable sign that a force beyond the standard playbook is at work. This isn't the kind of error you can pin on faulty instruments or a misaligned telescope. From Mauna Kea's towering peaks to the high desert skies of La Silla, the global network of observatories reports the same subtle offset. The simulated orbit, once a pristine, razor-straight trajectory, now carries a scar, an open wound between theory and reality that refuses to heal. For the first time, the orbit itself becomes the protagonist, a celestial rebel refusing to follow the rules of its predecessors. Astronomers turn next to the coma, that glowing halo of gas and dust trailing the intruder. If gravity can't explain the deviation, perhaps chemistry can. Every comet's coma is its fingerprint, a unique blend of ice and dust whispering secrets about its origins. But the fingerprint of 3I Atlas is something alien. The data from the James Webb Space Telescope is chillingly clear. For every single molecule of water vapor streaming from Atlas's surface, there are 8 molecules of carbon dioxide, an 8-to-1 ratio. This is not just unusual, it is off the charts, far beyond anything ever observed. Even the strangest Oort cloud comets bow to water as their dominant element. On most comets, carbon dioxide plays a minor role, a supporting actor in a drama dominated by water. But with 3I Atlas, the script has been flipped. Carbon dioxide calls the shots. It gushes from the nucleus at a staggering 129 kilograms per second, utterly dwarfing the meager 6.6 kilograms per second of water vapor. In theory, more gas means more thrust, each molecule acting like a microscopic rocket kick. But even when every molecule is counted, the math collapses. This is a leviathan. Its nucleus spans between 3 and 7 miles across. A bulk so immense the jets simply don't have the horsepower to explain its drifting path. The momentum just isn't there. The comet shrugs off the math as if mocking the very equations meant to bind it, and the chemical strangeness doesn't end there. Using the Very Large Telescope, astronomers turned their eyes to Atlas's spectrum and found something that stopped them cold. 22 distinct emission lines of atomic nickel blazing in the coma, yet not a single trace of iron. That is not normal. In the cosmos, nickel and iron are inseparable twins, forged together in the hearts of dying stars, side by side in supernova fire, blended endlessly in meteorites. But here, nickel stands alone, uncoupled, liberated into the coma by a process that seems to favor it over iron. Some speculate exotic chemistry could be at play, perhaps organometallic compounds breaking apart under solar heat, or nanograins unraveling in ways never before witnessed. The nickel jets erupt at an astonishing rate, 4.7 times 10 to the 22nd atoms per second. Their intensity steeply climbing as 3I Atlas draws closer to the sun. Even its dust output, measured by the Hubble Space Telescope, ranges between 6 and 60 kilograms per second, a respectable storm of particles by any standard. And yet, the numbers refuse to reconcile. The coma is alive, thick with carbon compounds, bursting with activity, shedding gas and dust in torrents. Every natural engine is firing, but the drift in Atlas's orbit persists, unmoved by the fury. The math still doesn't add up. For all the spectacle, the comet remains defiant. Jets are active, dust clouds swell, chemistry is exotic. And still, the trajectory mocks the models. Astronomers are left staring at the residuals, their instruments recording a rebellion they cannot tame. The conclusion becomes unavoidable. Gas alone cannot account for the deviation. Something vital is missing from the standard cosmic playbook. And this is not the first time the universe has forced such a reckoning. 6 years earlier, in 2017, astronomers faced a puzzle that still haunts them. A bizarre interstellar object, only about 400 meters long, tore through the solar system at escape velocity. It was named Oumuamua. Speed was not its strangest feature. Interstellar visitors must move fast. The shock came later when the data revealed something impossible. Oumuamua's path bent just slightly, in a way gravity alone could not explain. No violent outburst, no chaotic jet, just a tiny, persistent push. The numbers never lied. Oumuamua's motion revealed a residual acceleration of about 17 millimeters per second squared. Small, yes, but undeniably real. And yet, there was no visible coma, no whisper of gas jets, no haze of dust. Just a dry, tumbling shard slicing through space, accelerating as if nudged by an invisible hand. The headlines exploded. Interstellar visitor accelerates mysteriously. Comet or something else. Theories swirled like cosmic storms. Some insisted on hidden outgassing, perhaps hydrogen or some exotic material we'd never observed. Others suggested radiation pressure, the faint but constant push of sunlight, and a few dared to whisper the unthinkable. Maybe it was something engineered, but the truth was more unnerving. There was no clear culprit. Every model left a gap, a silence in the equations. The anomaly remained unsolved. Now, with 3I's Atlas, the déjà vu is impossible to ignore. Another interstellar stranger, another trajectory breaking the rules. Only this time, the difference is scale. Oumuamua was small, barely 400 meters across, fragile enough that a wisp of gas or the faint hand of radiation might have explained its drift. But Atlas is a Titan 7 miles wide. The force required to move such a behemoth is staggering, far beyond anything the usual suspects can deliver. And yet, astronomers are watching their models unravel again. The residuals keep stacking up, echoing the whispers of 2017. What once looked like a one-off mystery is beginning to resemble a pattern. Interstellar objects aren't just rare, they are unpredictable. They don't simply pass through our solar system, they rewrite the rules as they go. The true shock isn't only that Atlas is drifting, it's that for the second time, gravity alone has failed to keep the universe on script. Now picture the sheer bulk of 3I's Atlas. This is no pebble tossed across the stars. It is a cosmic boulder, a wandering mountain whose mass dwarfs anything we've ever seen in interstellar form. By every estimate, it outweighs Oumuamua thousands of times over. The numbers stagger the imagination. Even at the conservative end, Atlas carries a nucleus with billions of tons of inertia. To nudge something like this off course would require a force far greater than anything comets normally endure. For context, the Rosetta mission measured jets on Comet 67P, powerful enough to move mountain-sized chunks by a few kilometers per orbit. Impressive, but Atlas belongs to an entirely different weight class. Its colossal mass drinks in momentum like a bowling ball hurled into a sea of ping-pong balls. Every molecule of gas it expels is barely a whisper against the momentum of a freight train. The laws of comet physics are clear. More mass means less motion from outgassing. And yet, this Titan refuses to obey. Orbital modelers, watching the data unfold, see the giant shifting its trajectory in ways no equation can reconcile. The push required to explain such a drift would demand outgassing on a scale that simply does not exist. Even if every square inch of Atlas's frozen skin erupted in geysers of vapor, the total thrust still wouldn't scratch the surface of what's needed. This isn't just a matter of tweaking a parameter or adjusting a constant. This is a momentum budget gone bankrupt for an object this massive. To move an object of this magnitude, something immense has to be pushing. And right now, all the usual suspects are coming up short. Every standard explanation for 3I's Atlas's drift has been run through the gauntlet, and each one cracks under pressure. The jets don't add up. The dust isn't enough. The chemistry fails to explain the force. If outgassing and solar nudges can't budge billions of tons of rock and ice, then what can? Some astronomers reach for fragmentation, perhaps a hidden fracture inside the nucleus split open, shifting its center of mass just enough to alter the orbit. But no evidence of a breakup appears. Others propose Atlas may not be as solid as it looks. Maybe it's a porous rubble pile, loose enough to react more dramatically to small forces. Yet the chemistry of its coma doesn't support that either. And then comes the wild card. Harvard's Avi Loeb and a handful of scientific contrarians have suggested a possibility that sounds like pure science fiction. What if Atlas is being propelled by something more exotic? In a 2023 paper, Loeb explored the idea of a thin, ultralight sail, a structure riding sunlight the way a ship rides the wind. On a cosmic scale, such a sail could generate subtle but persistent acceleration, enough to explain the strange drifts we see. The numbers worked for Oumuamua, small and light. For Atlas, massive and heavy, the math is more daunting, but not impossible. If the body were hollow or engineered with a vast surface area, the push of sunlight could, in theory, move even this giant. No one in the mainstream is calling Atlas artificial, yet the fact that such possibilities are even whispered in the halls of science speaks volumes. This object is pushing astronomy to its limits, forcing us to question not just comets, but perhaps the very nature of what moves through our cosmic backyard. When gas can't explain the motion, physics leaves us no choice but to search for another answer, natural or not. With each failed explanation, the question only grows louder. What exactly are we looking at? And if our carefully built models crumble against Atlas, what other interstellar trespassers might already be slipping through the cracks, unseen? The next chapter is already writing itself. The Vera C. Rubin Observatory, with its revolutionary legacy survey of space and time, is about to transform our view of the skies. When Rubin powers on, astronomers expect to spot dozens of interstellar visitors every single year, maybe even more, which means that Atlas is not a once-in-a-lifetime anomaly. It is the harbinger of a flood. For the first time in human history, we will not be limited to rare cosmic guests. We will have a steady stream of messengers from distant suns. Each one will carry secrets in its chemistry, scars of its birth, and whispers of the alien star systems that forged it. Every new detection will be another test, another chance to catch a rule breaker that refuses to fit the script. But here's the catch. If our models can't even keep pace with Atlas, what unseen truths are escaping in the dark? The universe is not merely tossing us curveballs, it is pitching blindfolded, and we are still fumbling to connect the bat with the ball. Every anomaly is a stinging reminder that our grip on the cosmos is fragile, bound by equations that may only scratch the surface of reality. And this is why it matters. These objects are not just stray rocks wandering the void. They are time capsules from alien suns, relics carrying the raw chemistry, the lost history, the fingerprints of worlds we will never set foot upon. If we wish to understand our place in the galaxy, we must chase every mystery, every unexplained orbit, every outlier that dares to blur the line between natural and engineered. Because the next discovery may not just rewrite the models, it may rewrite everything we think we know about the universe itself. If you want to be there when the next revelation strikes, make sure you hit subscribe and tell us in the comments, what do you think 3I Atlas really is? On July 1st, 2025, astronomers confirmed the arrival of 3I Atlas, an interstellar behemoth racing through our solar system at nearly 60 kilometers per second. With a nucleus stretching up to 7 miles wide, it is the largest alien visitor humanity has ever tracked. Both NASA and ESA monitored its flight, only to discover a chilling anomaly. Atlas's orbit shifted in ways that defied every standard model of comet physics. The James Webb Space Telescope revealed its alien fingerprint, a staggering 8-to-1 carbon dioxide to water ratio, and nickel without iron, something never before seen in any comet of our solar system. For decades, cometary motion has been faithfully explained by outgassing, the push of vapor jets nudging icy nuclei along. But in Atlas, the forces are far too weak to justify the deviation. It is deja vu of 2017, when Oumuamua bent the rules in silence. Once again, the universe is taunting us, showing that gravity and jets alone cannot explain everything. What drives these anomalies remains unknown, whether exotic physics, unseen processes, or something even stranger. No consensus exists. The data is still under review. And soon, with sky surveys like the Rubin Observatory, ready to spot dozens more interstellar travelers each year, the floodgates are about to open. One truth stands undeniable. The rulebook for cosmic intruders is far from complete. So stay with us, subscribe, share this story, and drop your theories below. Could Atlas be a natural marvel, or something far more mysterious? Either way, the next discovery could change everything we thought we knew about the universe. We'll see you in the next one.